In this video, the past paper Mathematics Mechanics M1 January 2024 will be discussed. See the description of this video. The timestamp is given, so by using the timestamp you can directly go to a particular question in this paper. Also, by using the playlist of this channel, you can navigate to any lessons on in physics or mathematics. So you can use the playlist to navigate to any lessons related to physics or mathematics. Okay, January 2024, Mathematics Mechanics M1. First question, this diagram is given. Figure 1 shows a small smooth ring threaded onto a light inextensible string. So threaded means the tension will be the same on this part of the string, on this part of the string, both parts of the string coming out of the ring C, the tension will be the same string, so the tension will be the same. Right. So that's the reason they say threaded. So threaded is given in bold because it's just passing through the ring, same string, same tension. We take strings are light, inextensible, so there won't be any difference in the tension at any point of the string. One end of the string is attached to a fixed point A on a horizontal ceiling, and the other end of the string is attached to a fixed point B on the ceiling. Yeah, that's given on the diagram. A horizontal force of magnitude 2 Newton acts on the ring, so there's a horizontal force also acting on it. Rests in equilibrium, so the ring is in equilibrium, so the resultant force must be equal to 0. If you take moment about any point, that must be 0, but we don't need to take moments. Actually, I told in other videos also related to mechanics M1 or even physics. When an object is at equilibrium, the resultant force must be equal to 0. There should be two conditions satisfied. First, the resultant force must be equal to 0. That means if you resolve all the given forces to any direction, in that direction the resultant force must be 0. The second condition, if you take moment about any point, the total moment must be equal to 0. Or when you take moment about any point, the total clockwise moment equal to total anti-clockwise moment. But in situations, certain questions, depending on the type of questions, type of situations, we don't need to use moment. The principle of moment we don't need to use. Without using the moment, we are able to calculate the unknown thing which is asked in the question paper. But the moment must be 0 when a system is at equilibrium. We might not use, right? But that does not mean moment is not equal to 0. Moment must be equal to 0 when the system of forces they keep an object at equilibrium. Okay, so the horizontal force of magnitude 2 Newton acts on the ring so that the ring rests in equilibrium. A point C vertically below, so this is vertically below means this is 90 degree. This is 90 degree. Okay, vertically below B with the string taut. So the string is under tension, right? Okay. The line of action of the horizontal force and the string both lie in the same vertical plane. So they all are on the same vertical plane. So imagine it should be same as what I drew on the diagram. Okay, so they must be in the same vertical plane, right? Angle that the string makes with ceiling A is theta, where tan theta is 3/4. So tan theta 3/4 means anyway I need to find the use the trigonometry. I don't need to draw the diagram again like this. I can just draw the right angle triangle. So theta is given tan theta. Tan theta 3/4 means opposite to adjacent, that is 3/4. So by using Pythagoras theorem, this should be equal to 5. So we can say sin theta equal to 3/5, cos theta equal 4/5. Okay, so that we can find from the triangle. Okay, so the first question, the tension in the string is T. So that will be the same. I already told since the string is just passing through the ring, the tension will be the same at all points. So tension should be the same. Find the tension in the string is T newtons. The mass of the ring is m kilogram. Find the value of T. Okay, so that's the first A part. So we'll draw a free body force diagram. Free body force diagram means that shows all the forces acting on the ring. So if I draw the ring here, again this is the ring. So there is a horizontal force 2 Newton. So the tension, this part of the string is pulling the ring upward direction. So there will be a tension upward direction vertically up. So this is horizontal, inside there should be 90 degree. And there is a tension with horizontal line. This is theta means alternative angle, horizontal, this is theta, is it? Alternative angle. So there is a tension from this part. You can draw, yeah, it's passing from this part. I can take it like this. Yeah, this is passing through the center. If I take, this is tension T, that makes an angle theta with horizontal. Okay, and also the weight is given as M, the mass is given as M, so the weight will be mg, that is acting vertically downwards. These are the forces acting on the ring. Okay, so we should draw the diagram carefully. If the diagram goes wrong, then the calculations might go wrong, mainly in situation like conditions for equilibrium. Okay, so there we need to find the tension. So we know that first part they asked to find the tension. So it's at equilibrium means when you resolve all the forces. So there are 4 forces acting on the ring. These are the 4 forces. If we resolve these forces to any direction, the resultant force must be 0. But here I don't need to take moment about any point because the given ring is a small, the dimension is not well defined. So if it is something like a rod resting on 2 supports, there we take the moment also, right? But here also moment must be 0, but we are not going to use the principle of moment. But moment, total moment is equal to 0 here also, right? Okay, when I resolve all the forces to any direction, it must be equal to 0. So first part they asked to find the tension. So if I resolve the forces vertically, there will be 2 unknown in my equation. One unknown is T, the other one is M. Both are unknown. So I won't be able to find the T if I resolve vertical. That's a technique. Okay, you can resolve, but you won't get the answer. So we have to think about techniques, right? Now if I resolve all forces into horizontal direction, this will become T cos theta towards left, 2 Newton towards right. So T cos theta minus 2. Then this tension is vertically upwards. So vertical force has no horizontal component. This mg also vertically down. That also won't have any horizontal component. So in my equation, when I resolve all the forces horizontally, in my equation there will be only unknown T. M won't appear in my equation. So I can solve it and get the T. So that's a technique, right? Physics says, yes, if you resolve any direction, it must be equal to 0. But we have to use the technique also. We have to minimize the unknowns in our equation, right? So I resolve it horizontally. That means towards right, if I take it, 2 minus, this is T cos theta equal to 0. But cos theta, we know that 4 by 5. So when I take it to the right, T cos theta equal to 2 Newton. So T into cos theta equal to 4 by 5 equal to, solve it, you will get T is equal to 10 by 4, that is going to be 5 by 2 Newton. That is 2.5 Newton. Okay, so I know the T now. The second part they have to find the M, right? So to find the M, second part, resolve it vertically up, right? So when you resolve vertically up, there is already T. The vertical component of this T is T sine theta, that also upward direction, T sine theta. This is horizontal force, it won't have any vertical component. So this is downward mg, so minus mg equal to 0. Okay, so T I know that 5 by 2 plus 5 by 2 sine theta 3 by 5 equal to mg. Okay, solve this one. You will get mg is equal to 5 will get cancelled. 5 by 2 plus 3 by 2. 5 by 2 plus 3 by 2. That is 8 by 2. So that is going to be 4 Newton. So I need to find m, not mg. Mg is the weight, Newton. Divide 4 Newton by 9.81. That is the g. You will get it in kilograms. So that will be equal to 0.408 kilograms. That's the answer for m. Okay. Okay, question number 2. Figure 2 shows two particles A and B moving in opposite direction. There's a diagram given. According to that diagram, figure 2, a sphere A is moving towards right and sphere B is moving towards left. Mass of A is 5 kilogram, mass of B is x kilogram. The particles collide directly, head-on collision. Immediately before the collision, the speed of A is 3 meter per second and the speed of B is x meter per second. So I'll draw the diagram. This is A, 5 kilogram. It's moving towards speed of A is 3 meter per second. So this is 3 meter per second. This is B, the mass is x kilogram. Its speed is x meter per second. Opposite direction, x meter per second. This is before collision, B dot C dot before collision. Okay, after collision, immediately after collision, the speed of A is 1 meter per second and its direction of motion is unchanged. So A should move towards right after collision. So A after collision, it's 5 kilogram the mass. Its direction is not changing, means H that has speed 1 meter per second towards right and its direction of motion is unchanged. Immediately after collision, the speed of B is 1.5. Okay, what could be the direction? The speed of B also should be towards right. So the mass is x kilogram. Because we know 100% sure the speed of A or the velocity of A, according to the diagram they gave, A and B are moving towards each other. So the diagram shows A's arrow is given towards right, B is towards left, right. Then they are saying after collision the direction of motion of A is unchanged. Means A should move towards right. Nothing is mentioned about B. Immediately after collision, the speed of B is given 1.5. So normally students ask, should it be left or right? The speed of B or the direction of velocity of B should be towards right because B can't move towards left because we know 100% sure A is moving towards right means after collision when they collide they are going to collide like this. They are going to touch each other. Immediately after collision if A moves towards right, B can't move through the A to the left. B also should move towards right, is it? Because A won't allow the B to pass through it. That won't happen, no? Both are solids, so they can't pass through each other. So B also compulsory should move towards right. The direction of A after collision is not changing, mentioned in the question. So A moving towards right after collision means B also should move towards right. That's all the given diagram. This is after collision. Right. First part, find the value of x. That's simple. We will use the law of conservation of momentum. O-level IGCSE physics knowledge is enough to answer this question. So first part, use law of conservation of momentum. Okay, I'll use that law towards right. Before collision, the total momentum towards right. So mass 5 into 3. This is towards left. So plus x, the mass, into minus. Because it's moving towards left, I am taking towards right, positive. So minus x is equal to, after collision, A is moving towards right. 5 into 1. I am taking towards right, positive, velocity also towards right. 5 into 1 plus x into 1.5. Okay, solve it. So you'll get 15 minus x squared equal to 5 plus 1.5x. Okay, so it's going to be a quadratic equation. Solve it. So you know this is, you can write 1.5 as 3 by 2. If you multiply the whole equation by 2, you will get and rearrange it, it will become 2x squared plus 3x minus 20 equal to 0. So this is the quadratic equation. We need to solve it by using calculator. In equation mode, you can solve it or factorize it. You can factorize it. Anyway, you can use calculator, no problem. But if I factorize it, 2 into 20, 40. So that could be written as 2x squared plus 8x minus 5x minus 20. Anyway, I'm just doing factorization, but not necessary. You can use the calculator to solve and get the value for x. So that's going to be 2x, x plus 4, here minus 5, x plus 4 equal to 0. So it's going to be 2x minus 5, x plus 4 equal to 0. Anyway, you can solve it by using calculator. I'm just doing for no reason factorizing. So from this 2x plus 5 equals 0. So that means x equal 5 by 2 and or whatever you use, x equal minus 4. Okay, so here x cannot be minus because here they are saying the mass cannot be negative quantities. Simply I can say the mass cannot be a negative quantity. So the answer x equal 5 by 2, that is 2.5 is the answer. They asked to find the x. So that value of x is 2.5 because negative answer is not acceptable. Mass can't be, here the mass can't be negative. Or even here I can say if it is negative, they are saying it's moving in opposite direction, so it will become towards left, is it? That won't have a towards right, it will become if I take minus answer. Anyway, simply I can say x is a positive quantity, so it should be 2.5. Okay, second part, find the impulse exerted on A by B during collision. But anyway, if you find the impulse exerted by A on B or B on A, that will be the same. In other videos, M1 I discussed why should they be the same. You know the Newton's second law is the reason. I'll explain again. So if you draw the diagram during collision, if I consider during collision, they will be in contact, but I will put small gap between them. A exerts force on B. B exerts the same magnitude of force on A because according to Newton's third law. The forces exerted by A and B on each other will be the same magnitude, opposite direction according to Newton's third law. The forces will exist for the same time. Whatever the time duration A exerts the force on B, the same time period B will exert force on A. Okay, the reason for the change in velocity is the force. So if I think about Newton's second law, F equal ma, that is m into acceleration means general format v minus u over t. First multiply ft equal mv minus mu. So both are experiencing same magnitude of force for the same time means both will have the same magnitude of change in momentum. Both will have the same magnitude of change in momentum. Ft is the impulse. Ft is called impulse. Both will have the same force for the same time means both will have the same magnitude of impulse that will be in opposite direction. So if I mark the impulse, both will have the same magnitude of impulse for the same time. The direction of impulse is always along the direction of the force experienced by the object during collision. So the B experienced force towards right. So the impulse on B will be towards right. That is the change in momentum of B will be towards right. It's a vector quantity change in momentum. Same way the force experienced by A during collision is towards left. The impulse on A will be towards left. Change in momentum of A also will be towards left. Both impulse will have the same magnitude. The reason both experience force for the same time. Okay, so anyway the question says, find the magnitude of the impulse exerted on A by B. If you find the other way, impulse exerted on B by A, you will get the same answer. But we will answer to the question, B part. For A, I am going to write impulse I is equal to general format mv minus mu, final momentum minus initial momentum. So for B, I am on A, right. So if I consider A, the direction of impulse experienced by A is towards left. So the impulse is towards left. Okay, the mass of A is 5 kilogram. The velocity after collision for A is towards right, so I should put -1 because it's towards right. I am taking towards left, positive because impulse on A is towards left. 5 into -1. This minus 5 into initial velocity of A towards right. Sorry, I made a mistake. That's also towards right. I am taking towards left, positive, so -3. Okay, solve it. Minus 5 plus 15. So it's going to be 10 Newton per, we can say kilogram meter per second. So impulse experienced by A is 10 kilogram meter per second. That's the change in momentum of A. If you do it for B also, anyway, that's enough. We have done it. But if you do it for B also, just I show that, you will get the same answer. For B, if I say I is equal to mv minus mu, B experienced impulse towards right, so I should take that direction positive. So the mass of the B is x, that we found it 2.5. X is the mass of B, that we found it as 2.5. The velocity after collision is towards right into 1.5. That also towards right. I took towards right positive because impulse experienced by B is towards right. This minus, again the mass is 5 by 2, yes 5 by 2, that is 2.5, into the initial velocity towards left, x is 2.5. I am taking towards right positive, so minus 2.5. Solve it. You will get 10 kilogram meter per second. So both will have the same impulse. Okay, question number 3. It's on equations of motion. A van travels with constant acceleration, means the direction is not changing, constant acceleration along a straight horizontal road. So that means the direction is not changing. Acceleration, the numerical value is constant. Constant acceleration means direction also not changing. Magnitude of the acceleration is also not changing. But velocity will change. The direction is not changing the velocity, but the magnitude of the velocity, that is speed, will change. The van passes a point A with a speed u meter per second, and 20 seconds later passes a point B with speed of 28 meter per second. The distance AB is 400 meters. So if I put it on a block diagram like this, so this, if I take point A, this is point A when t equals 0. So at this point, the van, so I just put like a particle, its velocity is u meter per second when t equal 0. Then at B, the point B is passing when t equal 20 seconds. 20 seconds later means if I take, it passes the point A at t equals 0 means 0 seconds means after 20 seconds means when it passes the B, the time will be equal to 20 seconds. It is passing that at a velocity, the final velocity, that is 28 meter per second. The distance between A and B is 400 meters. Okay, show that u is 12. So we can use the equation normally. It's equal u plus v by 2 into t. U plus v by 2 is the average velocity. We can use only when the acceleration is constant. This is the average velocity into time. Okay, so this is 400. We need to find u. The final velocity is 28 over 2. The time taken to change of velocity from u to 28 is 20 seconds. That is the t. Solve it, cross multiply or divide this, it will be 10. 10 divided by this is 40. So 40 is equal to u plus 28. So u will be equal to 12 meter per second. Okay, first part over. Second part, find the time taken for the van to travel from A to midpoint of AB. A to midpoint of AB. So the midpoint of AB, if I call that C, the distance from A to C will be 200 meters. Okay, so the B part, find the time taken for the van to travel from A to the midpoint of AB. So midpoint of AB, we name it C, then that will be 200 meters. From A to C, 200 meters. From C to B, that also 200 meters because C is the midpoint. Okay, so the speed at C, we take it VC. So the question is, what's the time taken to move from A to C, where C is the midpoint? Okay, we can do that in different ways, but anyway, we need to find the acceleration, it's a constant acceleration. So second part, we'll find the acceleration by considering the motion from A to B, by considering the motion from A to B by using B equal U plus AT. We know the final speed 28, initial speed we found it 12, plus A into, we know the total time 20, solve it. 28 minus 12 will be 16, 16 divided by 20, so A is going to be 0.8 meter per second square. So that's the constant acceleration throughout the motion. Now we can follow many different methods, different equations. You know the equations of motion. We can use for the motion from A to C, S equal ut plus half at squared. If I use S equal ut plus half at squared, first method for A to C, A to C. S is 200 meters. The U is, we found it 12, so 12t plus half, acceleration 0.8 t squared. Rearrange it, 0.4, half into A, find it, 0.4 t squared plus 12t minus 200 equals 0. That's the time taken to move from A to C. C is the midpoint. Okay, so find the time here. When you solve, you'll get time 11.93 seconds, or and whatever it is, t equal minus 41.9 seconds. So that we can't take because time is a scalar quantity that won't have negative value. So the answer is 11.93 seconds is the answer. Okay, that's one method. Or you can find the speed at C. You know the distance it moves, so the method 2, this is correct, we have done it. But another method, second method I can say, we can say by using V squared equal U squared plus 2AS, little longer method, but you might do that way also for the motion from A to C. C is the midpoint. So I need to find the speed at C, VC squared, U squared is 12 squared, plus 2 into acceleration we found it 0.8. S from A to C, S is 200. So solve it and find the C, VC at point C. You will get the speed at that point, it will be equal to 21.54. Now you can use E equal U plus AT for the motion from A to C. So that is VC equal U plus AT. So VC is 21.54 equal U is 12 plus A 0.8, find the T. You will get the same answer 11.93. So that is second method. So this is one method. This is one method. We got the answer here. We get two answers, but negative is not acceptable. So this is one answer. This is second answer. Anyway, we are using the same acceleration. Okay, this is second method. If you want, you can use S equal Vt minus half At squared. That also you can use for the motion from C to B, right? You can do that way also. Okay, so we'll consider the motion from, this is the third method. But anyway, we need the acceleration, I raised it. S equal, same question we are answering, still second part. We use S equal Vt minus half At squared for the motion from midpoint C to B. Okay, C to B. So the meaning of this equation, during time t, when it travels for time d, at the end of time t, the final speed is v. During that time t, the distance travel is s. So during the time t, distance travel is s, means we are considering the distance travel from C to B, so that is 200. The speed at the end of that time is 28, so 28t minus half, the same acceleration, t squared. Okay, solve this one, 0.4 t squared minus 28t plus 200 equals 0. So again it's a quadratic equation. Solve it and find the time. You will get time t is equal to 8.07 or 61.92. Both are positive, 61.92. So okay, this is not acceptable because the total time taken to travel from A to B is 20 seconds. But here 61.92 is greater than 20, so can't be, because the C is midpoint of AB. The time taken to travel from A to B is 20. So the time taken to travel from midpoint to B should be smaller than 20. Can't be 61.92, which is more than 20, so it's not acceptable. So the time taken to move from C to B is 8.07. The question is the time taken to move from A to C. So time to move from A to C, A to C, total time we know that 20 seconds, C to B 8.07, so subtract it, you will get exactly the same time, 11.93 seconds. So anyway, either way you can find the answer. Okay, so now question number 3, C part. Find the magnitude of driving force exerted by the engine of the van as it travels from A to B. During its motion, the van experiences a constant resistive force of magnitude 20. So if I draw the van like a box, just like a box, right? So the driving force is the question, we need to find it. The friction or the resistive force is given, that is 260 Newton. So we know the acceleration, we found it 0.8 meter per second squared. Okay, the mass is given 1200 kilograms. So we'll use F equal ma. So driving force we'll put Fd. The question is about the driving force, yeah. Yeah, Fd. So F equal the resultant force, that is Fd minus Fr should be equal to ma according to Newton's second law, F equal ma. So driving force, we need to find it, Fd minus Fr is 260 equal to mass is 1200 into 0.8 acceleration. Find the Fd. So you will get 1220 Newton. Okay, so question number 4, January 2024, Mathematics M1 paper, Mechanics M1. Okay, figure 3 shows two horizontal forces P and Q acting on a particle. So this diagram is given on the question paper. The angle between the direction of P and the direction of Q is 150. Direction of P is this way, direction of Q is this way. So it's an obtuse angle 150 degree. Force P has a magnitude x Newton, force Q has 5√3. So 5√3 means if you find it in decimals, so that will be equal to 8.66 Newton. So this is 8.66 Newton, right. The resultant of these two forces, P and Q, is square root of 129. So the resultant force given, that is 129 Newton is given. So how much is it? 129. If you find it in decimal, that will be, we don't need to find, I'm just finding it, 11.36 Newton. That's the resultant force of these two. Right. The question is, first part, find the value of x. Second part, the angle between Q and the resultant, giving you answer to the nearest degree. Okay. Anyway, we need to find the unknown force x and the angle between the resultant and Q. Only the resultant magnitude is given, direction is not given. So we need to find the direction, that is in terms of angle between the direct resultant and the Q. Okay. This could be done in different methods. One, just by considering the vector triangle for the given two forces and the resultant force. Then after that we can use the geometrical approach by using sine rule or cosine rule. We'll do that as a first method. So if I approach that way, method 1, Both together, they asked to find the value of x and the angle between the resultant and the cube. Both together, the same marks 8 is given. So we had to find both together. Right, okay, if you draw the vector diagram, you know the vector addition rule. Tip to tail, right? That means at the end of the first vector, the second vector should follow. From the end of the second vector, third should given vector should follow, and the resultant should be drawn from the most initial to the final point. That you know that. So the resultant, if I draw the vector diagram, this is 5 root 3 towards left. So I should draw a line this way. 5 root 3 towards left means it should be like this. This is 5 root 3, that is the force Q. Right, that's the first force. The second force should be drawn from end of Q, so at 30 degree. We don't know the magnitude of x, just I am sketching 30 degrees. If I draw it at 30 degree, the second force, that is x Newton, unknown, we know this is 30 degree. Right. So the resultant of this means, if I name this triangle A, B, C, where to put the C is the question. Should I put the C somewhere here or here or here, right? The resultant, the connecting point from A to C is the resultant. This is one force, 5 root 3. From the end of B, the second force is drawn. Alignment is the same. Alignment of this force is the same towards left. This is at an angle 30 degree in this angle. Or if I consider this angle, this is 150 degree. I don't need to show that. This is 150. I don't need to show that 150. And this is 30 degree. So where to put the C? If I connect A to C, that will be the resultant. So the magnitude of C is unknown. If the C is somewhere here, this angle will become acute angle. If the C is somewhere here, this angle will become obtuse angle, is it? Where should I put that C? Okay, we'll think like that. We'll plan it first. Okay, we can think like this. Okay, imagine there's a geometry. There's a horizontal line. This is 30 degrees. This length is AB is 5 root 3. So 5 root 3, I told that is 8.66. 5 root 3. That means it's equal to 8.66 meters. You'll think that way, meters, or in terms of length, 8.66. If it is 45 degree, then if I draw a vertical line from here to here, that length also will be equal to 8.66. If this is 90 degree, if this is 45, this also will be 45. Then this length will be equal to this length. But here this is not 45. This is smaller than that angle, 30 degrees. It should go something like this. So this length will be certainly smaller than 8.66. The resultant is, we know that 11.36. So the resultant cannot be this side, because this length is the maximum in this direction, 8.66. Whatever the line you draw here will be less than 8.66. Even the vertical line will be smaller than 8.66. But we know that 11.66 means it has to be somewhere here. This angle should be obtuse angle. So the resultant should be somewhere here. We have to draw the point C should be somewhere here. And if I connect these 2 points, the angle between the line AB and AC, it will be obtuse angle. This angle theta is obtuse angle. We have to find that theta. We will keep this angle alpha. Alpha also unknown. Right. So I drew the vector diagram. I hope you understood the idea how I found this as an obtuse angle. Okay, now I can use, we know this. This is the resultant force. So resultant force is given by 2 arrows. That is given as square root of 129 Newton. That means 11.36. Okay, so I need to find x and theta. Simple, one line we can get it. Use sine rule. So what sine rule says? The opposite side over a particular side over opposite angle. So that means we know this length 11.36 or square root of 129 over sine theta, or sine theta over length. Either way you can use the sine rule. All are the same. So square root of 129 over sine 30 equal, if you want you can find this theta, but you will get acute angle. The reason, sine 180 minus theta is equal to sine theta. In the second quarter, the sine value is positive. So here when you solve it, you are going to get positive value, and you will get angle. If you put it in the calculator, you will get the angle in the first quarter. So you have to, you know that, but you know this angle is acute angle. So you have to subtract 180 minus that one to get the actual angle theta. Okay. Or you can do like this. Find the alpha. That's easy. Rather than getting that confusion, find the alpha. That is 5 root 3 over sine alpha. We know everything except sine alpha. So find alpha. Solve it and find sine alpha. Make the subject cross multiply and find the alpha. You will get alpha will be equal to 22.4 degree. So what is theta? Theta means total addition of the internal angle is 180. So theta is will be 180 minus 30 plus alpha, that is 22.4. You will get theta, that is 127.6. Nearest angle 128 degree. Okay, we need to find the x. Not a big issue. We can continue now. We can continue that now. So I know the alpha, so I can use this one, square root of 129 over sine 30 equal x over sine theta, that is sine 127.6. Find x. So you will get almost 18 Newton. That's first method. Okay, so this is the method 1. Method 2, I'm going to use cosine rule. Okay, so that's the second method. Method 2, I'm going to use cosine rule. I'll erase it now. Okay, we'll use cosine rule. Method 2. You know, r squared is equal to x squared plus y squared or x squared plus this squared minus 2x into 5 root 3 cos 30. You know the cosine rule. All books they have. So we are going to use r squared is equal to, I'm going to substitute r squared 129 square root its square. R squared is equal to x squared plus 5 root 3 squared minus 2 times x times 5 root 3 cos 30. So r squared is, r is 129, r squared is 129, square root its square is 129 equal x squared plus 5 root 3 all things squared, 25 into 3 75 minus 2x 3 cos 30. So if you solve it, you will get minus 15x. Check it, minus 15x, you will get it. Because cos 30 root 3 by 2, if I solve it separately, 2 into 2x into 5 into root 3 cos 30 root 3 by 2. So 2 will get cancelled, and 2 and this 2 will get cancelled. Root 3 into root 3, 3 into 5, 50. Okay, so minus 15x. Okay, so now it's a quadratic equation. Rearrange it. It's going to be x squared minus 15x, 75 minus 129, that will be minus 54 equals 0. You can factorize it, but waste of time. Just you can find the value of x by using calculator. You will get where the value of x is 18 or x is minus 3. Okay, so here x is minus 3 is not acceptable because magnitude of x is a magnitude. Magnitude can't be negative. Magnitude means the numerical value can't be negative. So this is not the case. So x is equal to 18. Okay, so magnitude. So magnitude won't be negative. So x is equal to 18. Right, we found that one. Okay, so I need to find this angle, the angle between the resultant and the question says, the second part, the angle between Q, this is the Q is 5 root 3, this is the Q, angle between Q and the resultant. So this is the resultant, I need to find the theta. How to find it? Okay, we'll use a simple geometry. We'll draw an adjustment here like this way. We'll extend this line. We'll draw a line from here. So ABC, name this point D. Okay, so how can I find the angle theta? We know the x, we found it now, x is 18, so I'm replacing this 18. Okay, this is 5 root 3. And the resultant, we know that square root of 129, so that is 11.36. So this is 11.36. This angle theta means this will be 180 minus theta. 180 minus theta. Okay, so if I consider this right angle triangle BDC, so I'm going to consider two right angle triangles. So if I consider right angle triangle BDC, this is the vertical side in that triangle DC. If I consider the right angle triangle ADC, in that triangle also DC is the same common vertical side. So I can say AD, will consider the right angle triangles BDC and the right angle triangle ADC. So there DC is equal to in this right angle triangle BDC, that will be 18 sine 30, 18 sine 30. That is in this right angle triangle, that is going to be 11.36, that's square root of 129. So 11.36 or square root of 129 sine 180 minus theta. Is it? So sine 30 is equal to half. So that will be 18 into sine 30 is going to be 18 into half. So that is 9 is equal to square root of 129 sine 180 minus theta. Second quarter, 180 minus theta sine theta. Okay, so sine theta is going to be 9 over square root of 129. You will get a value for theta that will be acute angle, but we know that it's an obtuse angle. You have to find 180 minus theta like that. Okay, so find the theta value here. So you'll get 52.4. It looks acute angle 52.4 degree, but I already explained when I start this, it can't be acute angle, it must be an obtuse angle. I told that if it is 45 degree like that, so this length is larger than this length, so it must be obtuse angle, but you are getting sine. When you put it in the calculator, you will get 52.4 degrees. So we know that sine 180 minus theta equal to sine theta. Therefore, this theta should be equal to 180 minus 52.4. That will be, you'll get the same, that is 127.6. But they asked to give it to the nearest value, 128 degree. Because we know that it's an obtuse angle, not acute angle. So if this is 128, this is 52. This is acute angle, that is 52.4. I don't think it will be confusing you. It's simple because the trigonometry, the second quarter is positive, whether 180 minus theta or sine theta, the same value you will get it. So when you put it in the calculator, it gives the answer for the acute angles always, when you take sine inverse. But we know it's not an acute angle, it's an obtuse angle, we know that. We have the reason. Okay, method 3. Right, so next I'm going to do method 3. There's a normal method, resolving the given vectors. Okay, so the method 3 is very simple method, but might take longer steps. Resolve all the given vectors into horizontal direction. In physics, we don't use sine rule or cosine rule, so we use this method. You also can do it's given in the mark scheme, I think. Resolve all the given vectors, only two vectors given, into horizontal direction and find the total horizontal component of the given forces. Then resolve all the forces into vertical direction and find the total vertical component of the given forces. Then use Pythagoras theorem to find the resultant. Resultant is given, so we can find the unknown force x. Okay, so we'll find the total horizontal force, the method 3, Fh. I take the towards right is positive. So if I resolve this one, it comes to the right. So x cos 60, x cos 30 minus 5 root 3. So that is the total horizontal force. X cos 30 minus 5 root 3. Or you can resolve it left or right, whatever it is. So that's the total horizontal force, right? Total vertical force, if I resolve it, this is a horizontal vector that won't have any vertical component. So it's going to be x sine 30. So vertical component x sine 30. Okay, so if I take the vector diagram of it, horizontal component, the vertical component, FV, that will be the resultant. This is going to be the resultant force in the vector diagram. Okay, so it's a right angle triangle, this FV. Okay, so to find the resultant force, simply we can use Pythagoras theorem, is it? If you use the Pythagoras theorem, R squared is equal to FV squared plus FH squared. R squared is square root of 129 given its square. FV square, F is x sine 30, so sine 30 is equal to half, so x by 2. So that is x by 2 all in squared plus FH we found it like x cos 30 is root 3 by 2. So x root 3 by 2 minus 5 root 3 all in squared. Okay, so we have to solve it. We are going to get a quadratic equation when we solve it. So this will become 129. This will become x squared by 4. So when you square it, it will become x squared into 3 over 4. This is 5 into squared, that is 25. Square root of 3 squared is 3. So it's 25 into 3 is 75. A squared plus b squared minus 2ab. Minus 2ab. When you multiply these two, 2 will get cancelled. Root 3 into root 3, 3. So solve it and get it. You will get on left side 129. I'll write it here. 129 is equal to x squared by 4. Solve it. X squared by 4. And here you will get plus 3x squared by 4. 3x squared by 4 plus 5 in squared is 25 into 3 is 75 minus 2 into this into this, so minus 2 into x root 3 by 2 into 5 root 3. So you will get 129 equal x squared by 4, 3x squared, 4x squared by 4, that is x squared plus 75 minus here 2 and 2 will get cancelled 3, so it's going to be 515. It's going to be root 3 into root 3, 3, 3 into 5, 15. Okay, so minus this is 2 and 2 will get cancelled, 5, 3 minus 15x. Okay, rearrange it. X squared minus 15x, 100, so that is minus 54 equals 0. Check this equation when I did with cosine rule. There also we got the same equation, right? Okay, so solve it by using calculator. You will get x is equal to 18 or minus that will be 18 or minus 3. So negative answer is not acceptable because x is the magnitude. So we don't consider this. So x is equal to 18 is the correct answer. Okay, I need to find the angle. So the resultant force is this way. The Q is this way. The direction of Q is towards left. The Q is this way. The question is we need to find the angle between the Q and the resultant. This angle I need to find it. Okay, so we'll find this angle first. That is theta if I say. We'll find the theta, then we'll find this angle. The question says angle between the Q and resultant. So in this right angle triangle I can find the theta. So to find the theta, I should know the vertical component and the horizontal component. I'm going to find it. Since I know the 18, x, I can find the horizontal component. I can substitute 18 here and find the horizontal component. I can substitute 18 here and find the vertical component. Then I'll find tan theta and I'll find the theta here. Okay, I'll do that now. Okay, so I'll find the horizontal component. That's going to be x is 18, cos 30 is root 3 by 2 minus 5 root 3. So solve it. The horizontal component you will get 6.93 Newton. That's the horizontal. So this is 6.93. That is FH. FV, that is x is 18 divided by 2. So that is 18 by 2 is equal to 9 Newton. So this is 9 Newton. We'll find the theta. So tan theta is equal to, we'll find the tan theta. So tan theta is equal to 9 over 6.93. Find the theta. You will get theta 52.4 degree. But the question is between Q is towards left. Between Q and R means we need to find the alpha. So alpha is equal to 180 minus theta. So 180 minus 52.4, that will be 127.6 degree. So that will be 128 degree. Anyway, one of the three methods you can answer. Okay, so question number 5. A beam AB has mass 30 kilogram and length 3 meters. So length is 3 meters, AB, mass is 30 kilogram means weight is 30 into G, 9.81, I put it as G. The beam rests on two supports C and D, so there will be normal reactions R1 and R2. The distance of AC, DB are given 0.4 that I showed on the diagram. A person of mass 50 kilograms stands on the beam between C and D. The person is modeled as particle P, and at point P. So the person is standing at P. So his weight will exert a push on the beam. So the push by the person on the beam is equal to his weight, that is 55 kilogram into G, 9.81. So I put it as 55 G. The distance of the person from C is X. I mark it on as X. X is less than 2.2 and it's a positive number greater than 0. The beam is modeled as uniform rod resting in equilibrium. So uniform rod, so the weight will act exactly at the center. Normally the center of mass is denoted by G. So G will act exactly at the center. That means distance of G from A is half of 3, which is 1.5 meters. Okay, show that the magnitude of reaction at C. Magnitude of reaction at C means they ask you to find R1. Okay. Now, I told that the system is in equilibrium. Resultant force any direction must be 0. That is total upward. Here, there are no horizontal forces. So, we don't need to consider anything in horizontal direction. But when we consider vertically, the resultant force in vertical direction must be 0. Or total upward force equal total downward force. And also, turning effect, that is moment about any point must be equal to 0. Any point we can take moment that must be equal to 0, right? That's the only principle. The two principles we are going to use, resultant force, any direction equal to 0. So here vertically, horizontally no force. So only thing we are going to consider vertically, the resultant force must be 0. And moment about any point must be, the total moment about any point must be equal to 0. Or about any point, the total clockwise equal to total anti-clockwise. Either way, we can say the principle of moment. So here when we consider that resultant force or the reaction force at C, we should try to minimize the unknown in our equation. We can take moment about any point, but if I take moment about A, both R1 and R2 will appear in my equation. If I take moment about any other point also, both R1 and R2 will appear in my equation. If I take moment about C, R1 won't appear in my equation because the normal reaction, the R1 is passing through C, the distance of R1 from C is 0, so R1 won't appear in my equation, but R2 will be there. No point of finding it because they are not asking to find the R2, they are asking to find the R1. So the technique here, we should minimize the unknown in my equation, means I should take moment about D. So if I take moment about D, I can find the distances for everything, but they asked to find the reaction force in terms of x, so I don't need to worry about x in my equation. But if I take moment about D, R2 won't appear in my equation, only R1 will appear. I can find the R1, that is the question. So we'll take moment about D, first part. Okay, so if I take moment about D, I can take clockwise or anti-clockwise direction. So if I take clockwise direction in moment about D, okay, clockwise direction positive mean, anti-clockwise direction moment I should take negative, is it? So if I take from here R1 into the distance of C from here, so that means 3 minus 0.8, this is 0.4, 0.4. So 3 minus 0.8 is the distance of C from D. So R1 into 3 minus 0.8, that is 2.2. So 3 minus 0.8, I can directly put 2.2. Yeah, R into R1 into 2.2. Right, that is clockwise direction I am taking moment. So about D, this is providing clockwise direction, is it? Okay, so when I consider 55 kilograms, it's going to provide anti-clockwise moment. So minus 55 G into the distance of P from D is, distance of C from D is 2.2. So that distance minus x. So that is 2.2 minus x. That is the distance of P from D. Okay, this also providing anti-clockwise moment. So minus 30G into the distance of G. So this is 1.5 minus 0. Because this is center point, uniform rod. So 1.5 from here to there. 1.5 minus 0.4, that is 1.10. Okay, so rearrange this equation. So you will get 2.2 R1 is equal to, rearrange it, 30, that is 30 G into 30 into 9.8, 9.8, 30 into 9, take the right, 30 into 9.8 into 1.1. So take also to the right, plus 55 into 9.8, 2.2 minus x. So that is 30 into 9.8 into 1.1, that is 323.4 plus 55 into 9.8 into 2.2, that is 1185.8 minus 55 into 9.8 into x, that is 539x. Okay, so divide the whole equation by 2.2, you will get R1 is equal to 686 minus 245, 245x. Nothing. Solve it and get that equation. Okay, so second part, the B part, the magnitude of the reaction force at C, magnitude of reaction force at C, that is R1, is 4 times the magnitude of the reaction force at D. So compared to this is 4 times the magnitude of reaction. So if I say this is 5 Newton, this will be 20. This is 10 Newton, this will be 40. Like that, 4 times. R1 is 4 times of R2. Right. By using the model, find the value of x. Okay, now look at here. We have found simply the expression for R1, not for R2. If we want, we can find it again. So if you start like R1, this is 4 times, this is actually 4 times of this one. So if I put this one as 4R2, if I sometimes they say this is R2, this is 4 times, means they replace R1 as 4R2. You can, but we don't have any expression for R2 here. We have expression for R1. So we'll try to give R1, R2 in terms of R1 to find the x. Otherwise, we had to take moment again. So to avoid that, it's a technique, nothing, right? So we'll give the expression of R2 in terms of R1. This is 4 times, means this is 1/4 of R1. That's easy, 1/4 of R1. Don't give R1 in terms of R2 because we don't have any expression for R2. We have only for R1. And they ask me to find the value of x. So we need a relationship for R. If I put it in terms of R2, I need to find an expression for R2 again. Waste of time. So to avoid it, we'll give the R2 in terms of R1. Right? So this is 4 times of this one, means this is 1/4 of this one. Right? We know that. So B part, what I did is A part. A part. So I put it as first part, that is A part, we answered already. Now B part, so that's a technique actually, not physics, it's technique, right? So we know that R1 plus R2, the total upward force equal to total downward force, or resultant force must be 0. So R1 plus R2, if I take consider upward direction, R1 plus R2 minus 55G minus 30G equal to 0. So that is going to be 85G. So instead of R2, I am going to substitute 1/4 of R1. So R1 plus 1/4 of R1 equal to 85G. So find the R1 in terms of G. So you can substitute the value of G also there. So R1 is equal to, that is 5 R1 over 4 is equal to 85 into 9.8. So find the R1, solve it. You know everything. Find the R1, you will get R1 666.4. If I find R2, then problem because I don't have anything here R2. Now I know the R1. Substitute the R1 here, find the x. So we know that R1 is equal to 686 minus 245x. Okay, so carefully use the technique. Don't find in terms of R2. Don't put this as 4R2. Then you will find the R2. Then you have to find the R1. You can, but you have to keep it that format, right? So R2 is 666.4 equals 686 minus 145x. Solve it and find the x. So you'll get x 0.08 meters. Or if you want, you can give it in centimeter, 8 centimeter. Okay, part C. The person steps off the beam and places a package of mass m kilogram at A. So this would be there. So a package of m kilogram at A. So there will be mg at A, right? The beam is now on the point of tilting about C. So it's going to slightly lift away from D and going to stay only on C, but the lift is remaining in horizontal. So just lifting means R2 will become equal to 0, no contact. It's going to slightly tilting about C means it's leaving the contact with D. So R2 will become equal to 0. Using the model, find the value of m. So here we'll take moment about c because unknown force R1 is at c. To reduce the unknowns, to find the m, better take moment about c. So c part, take moment about c. So we'll take moment about c in anti-clockwise direction. So mg into 0.4, that's the only force this side, minus only the second force in clockwise direction, that is 30g, into distance of 30 from C is, this is 1.5 minus 0.4, that is 1.1, equal to 0, because R2 is 0, it's going to tilt, that is slightly move away from the contact point from D. Okay, solve it, that is 0.4 into 9.8. Anyway, G is going to get cancelled, so I don't need to put G here. This G and this G will get cancelled. So 0.4 into M is equal to, take it to the right side, 30 into 1.1. Find the M. You will get 82.5 kilogram. Okay, the mass M is 82.5 kilogram. Okay, question number 6. It's on equations of motion, motion under gravity. A particle is projected vertically upwards from a point A with a speed of 24 meter per second. The point A is 2.5 meter vertically above point B. So point B lies on horizontal ground. The particle moves freely under gravity until it hits the ground at B with velocity v meter per second. After hitting the ground, the particle does not rebound. Find the value of v. Okay, so like this. So this is the point A if I put it on a diagram. So this is the point A. From there, the particle is projected at the initial velocity 24 meter per second. So it will move up, decelerate, comes to rest at the highest point, then it will fall down and draw slightly on the side, and it will go on the same line to a point B. It's on a horizontal ground, they are saying. Okay, so when it hits the ground, its speed is v meter per second. So v meter per second, this is v1, highest point where the speed is 0. The distance of B from A is given as 2.5 meters. This is 2.5, the height difference between A and B, 2.5 meters. Okay, so the first part, they asked to find the value of V. Okay, so you know the equations of motion, v squared equal u squared plus 2as you can use. The final speed is the question, which is downward. Initial velocity is upwards 24. Throughout the motion, it's decelerating, it's accelerating. But decelerating, accelerating, careful, students things when we use the equation here, it's moving up, decelerating, then it's moving down, accelerating. But throughout the motion, the direction of the acceleration is not changing. The direction of the acceleration throughout the motion is the gravitational acceleration, which is 9.8. So remember that. Whether the ball is moving up or down, whatever it is, the direction of the acceleration is not changing. So why the ball is decelerating when it moves up? When it moves down, it's accelerating. Decelerating to highest point, then accelerating from highest point to ground means the direction of the acceleration is not changing. It's the same throughout the motion. Whenever a moving object has velocity along the direction of acceleration, the object will accelerate. Keep it in mind. Whenever a moving object has the direction of velocity along the direction of acceleration, the object will accelerate. Whenever object has velocity opposite to the direction of acceleration, the object will decelerate. So here, naturally, the gravitational acceleration is downwards. We can't change it whether the ball moving up or down. We can't change it. But when the ball moves from A to the highest point, the velocity is upward direction, acceleration is downward, so it decelerates. When it moves from highest point to the ground, the direction of acceleration still remaining the same, downwards, velocity also downwards, so the ball accelerates. Okay, so throughout the motion, if I consider the whole motion from A to B, so it's not falling from A to B, it's moving up then coming down. So when I consider the whole motion, the direction of the acceleration is not changing, it's remaining the same downwards, only the direction of velocity is changing. If the velocity is along the direction of acceleration, it's accelerating. When the velocity is opposite the direction of acceleration, it's decelerating. Carefully. Okay, so here the question is find the v. So for the whole motion from A to B, I will use v square equal u square plus 2as. So I can use a sign, but anyways this is not a vector, it is a scalar equation because squares are coming, dot product you don't need it, but anyway. So v square is the question when it for the whole motion from A to B. Okay, I am considering from A to B. Right. So v square is the question. U square is upward, so 24 square plus 2 into, okay, I am considering downward direction. Acceleration also downwards, 2 into 9.8 into, S is the displacement. Carefully in these equations, S equal U plus V by 2 into T, S equal U plus V by 2 into T, or S equal ut plus half at squared, or S equal Vt minus half at squared. In all these equations, S is the displacement, not the distance. When object moves on a straight line along the same direction from A to B, the distance and displacement are the same. Distance and displacement are the same. But if an object is moving at constant acceleration is something like that. It's moving up then coming down. When I consider the S for the motion from A to B, that is not the whole length, S is the displacement, shortest distance between A and B, so 2.5. So 2.5, S is the displacement, not the distance, right? 2.5, solve it and find the V, you'll get the answer. You'll get 25 meter per second. Since I am using this equation downwards, I put minus 24. Anyway, square minus become plus. It's not an issue, right? Second part, find the time taken for the particle to reach B. Means they ask you to find the total time to move from A to the highest point, then from highest point to the B. Okay, so here you can find in two different ways. Sometimes students they find the time taken to reach the highest point. From here they find T1, then from highest point to the ground T2 they add it. Okay, no problem, but it's longer step. We can do that way also, nothing wrong. But when you are using these equations, V equal U plus AT, S equal UT plus half AT squared, S equal VT minus half AT squared, or S equal U plus V by 2 into T, they all are vector equations. They are initial final velocity. U and V are the velocities. So if I consider the equation, method 1 I'll do, that is this is A, not first part, this is A part. Now we do it for the B part. B part, method 1, the simple method with meaningful. I'm going to use V equal U plus AT. I know the final velocity is downwards, so I'll use it downward. If I want, I can use it upwards. For the whole motion, A to B. I'm considering from A to B, so going up and coming down for A to B. So throughout the motion, acceleration is down. I'm using downward direction. So for me, A will be positive. I'm taking downward direction positive. Throughout the motion, A is not changing. Careful. That's the biggest mistake students make. Okay, V downward, that is 25. U is upwards. I'm taking downward positive, but U is upwards, so minus 24. Plus A is downwards. I'm taking downward positive, so 9.8 T. Solve it. That is 9.8 T equal to 25 plus 24, 49. Find the T. So that will be 5 seconds. Okay, so method 2, question number 6, part B, method 2, we'll consider the motion from A to the highest point, A to the highest point. So we can use V equal U plus AT. I am taking upward direction positive. So V is the final speed at the highest point, which is 0. Initial speed at A is 24 plus minus 9.8, because A is anyway downward, you can't change it. I am taking upward positive, so minus T1. Find the T1. 24, bring it to the left. This is 9.8, T1 equal 24. So you will get T1 will be equal to 2.45 second. Right. Now I need to take the whole time, is it? I need to find it. So then from the highest point to B, so from highest point to B, same thing I am going to use, V equal U plus AT, downward direction, because moving downward direction. So at B, the velocity is the final velocity, that is, we found it, 25. U is the initial velocity at the highest point, which is 0. Acceleration is downwards. We are using downward positive, so 9.8 T2. Find the T2, you will get 2.55 seconds. So total time, the question is about how long it takes to reach B from A, total time, T1 plus T2. So 2.45 plus 2.55, you will get 4.99. Earlier we got exactly 5, but here 4.99, because here we made approximation. So if you use all the decimal points, you will get exactly 5 seconds. Same answer we are getting, but little long step. Okay, so same question, question number 6, part C. The point C is 10 meters vertically above A. So this is the point C, which is 10 meters above point C. Find the length of time for which the particle is above C. So the length of time the particle is above C means the time taken by the particle to move from C to the highest point, that motion, and from highest point to C again, what's the total time taken? C to the highest point, then highest point to C, what's the time duration for that complete motion? C to the highest point, then highest point to the C. That is the question we need to find it. So we can do in two different methods is the best normally. Simple method is we'll use S equal ut plus half at square. You will get a quadratic equation for the motion from A to C, right? C part, I am going to consider for the motion from A to C, right? If I find the time taken for the motion from A to C, upward direction, S equal ut plus half at squared. I told that S is a displacement. Displacement means the shortest distance between initial point and the final point. I am considering initial point as A, final point as C. So A to C I am considering. So the S is 10. Right? S is the displacement, not distance. S is the displacement. So A to C, S is 10. Initial velocity at A is given, that is 24 meter per second. It was thrown upward direction, 24 meter per second. So 24 into T plus half. I told that already. I am using upward direction. Acceleration is G, which is downward direction. Whether the ball is moving up or down, there is no change in the acceleration. It's always directed down. So I am taking upward direction positive, means it should be minus 9.8 T squared. Okay. Now rearrange it. So that means you'll get minus 4.9 t square. So 10 equal 24t minus 4.9 t squared. So rearrange it, 4.9 t squared minus 24t plus 10 equals 0. Now when you solve this, you'll get two real values for the time. Two real positive values, time positive values, you'll get two real values. What do you mean by two real values for time? Means I told S is the displacement. So the ball when it is moving up, this is the point A. When the ball is moving from A to the highest point, it will be at point C, which is 10 meters above it. Displacement. Initially, finally, the displacement. So when it's moving up, once it will pass the point C, for that we will get a real time. Then it's moving up, decelerate, reach the highest point. When it coming back also, again it's going to pass the point C. When it is passing the point C, again it will be 10 meters above A. So the ball during its motion from A to B, twice it's going to pass the point C, once in upward direction, then it's in downward direction, velocity. But the displacement, when you consider A as the initial point, C as the final point, when it is moving up, it will pass the point C where it is at C 10 meters above A. Then when it is coming back also, the velocity is down, but it's still above A. So in both situations, whether the ball is moving up or whether the ball is coming down from the highest point, when it is passing the point C, the displacement is from A upward direction 10 meters. So if you solve this, you can say T1, two answers. I will put T1. T1 you will get, when you do this, you will get T1 that is equal to, you will get T1 0.46 seconds. T2, the second answer of this solution, I will put T1, T2, the two real values, 4.44 seconds. So the smaller value, 0.4 second, is the time when it moving from A to C upward direction. This is the longest time, that is after reaching the highest point to come back to C. The total time to move from here to the highest point and then to come back to C is 4.44. So during 4.44, it has moved from A to the highest point, then has come back to C. That is 4.44. 0.46 move from A to C. So if I subtract T2 minus T1, that is the time to move from C to the highest point again to the C. That is T2 minus T1. So the time duration when the ball is above point C is T2 minus T1, that is 4.44 minus 0.46. So that will be 3.98 seconds. I hope you understood that. Okay, so method 2, that's the same question. We'll do it in a different way. That way friends understand more. But anyway, this also seems nothing. So here we consider the second method like this. We'll find the velocity at point C. When it moves from A to C, we'll find the velocity at point C. We'll call that velocity Vc. So I'm going to find the velocity Vc by using v squared equal u squared plus 2as for the motion from A to C. Then I'll find the time taken to move from C to the highest point, v equal u plus at. So I'll find the time to move from C to the highest point. Then the time to reach the C from the highest point will be, say, if you throw something under gravity, the time taken to reach from this point to this point and to come back is the same time. So if I find the time to move from C to A, multiplied by 2, you will get the total time the ball is above C. That may also, we can do it as a second method. So method 2, for the motion from A to C. So we'll use upwards v squared equal u squared plus 2as. V squared means at C, that is Vc squared equal. Initially at A, we know the velocity 24 squared plus 2 into minus 9.8 into S is 10. Okay, so solve it and find the Vc. You will get Vc is equal to 19.49. So that's the velocity at point C. Right. Now I have to consider the motion from C to the highest point. Highest point if I consider. So there I'll use V equal U plus AT. Highest point the velocity is 0. Initial velocity is the velocity at C, that is 19.49 plus A is minus 9.8 because I'm using upward direction positive. So that's the reason I put positive. A is downwards, so minus 9.8, and find the time t. So solve it and find the time. So there when you find the time, you'll get 1.99 seconds. So that's the time taken to move from C to the highest point. Again from highest point to C, that time will be the same. Between 2 points under gravity, you learn that the same time. So to come back, the time will be the same. So the time duration the ball is above C means from C to highest point, from highest point to C, we have to multiply it by 2. So the total time duration above C equal 1.99 plus 1.99 or into 2. So you'll get 3 so that will be 3.98 seconds. Okay, same answer we are getting it. Okay, so sketch a speed time graph for the motion of the particle from projection to the instant that it reaches B. Okay, speed time graph, not velocity time graph. So speed time graph is a scalar quantity speed. So it will be always on the positive side. So this is speed, meter per second. This is time, second. So it was projected with velocity 24 meter per second. It's uniformly decelerating until the speed becomes 0 at the highest point. So the gradient of the speed time graph gives the acceleration. Acceleration is constant 9.81. So the gradient should be constant. So 0, the time taken to this point, we didn't find it. Anyway, we'll see. But this speed is we know 24. Then it's accelerating when it falls down until it reaches the point A. We know the total time for the whole motion from A to, they're asking A to B, we found the total time, that is 5 seconds, we found it. So again the acceleration is constant up to 25. So the total time is 5 seconds. The speed is 25 when it reaches the point B. Okay, question number 7, it's on vectors. In this question, I and j are horizontal unit vectors directed due east, due north respectively, and position vectors are given relative to a fixed origin O. Right. At midnight, a ship S is at a point with position vector 99 plus 22j. That's a position vector of the ship at a point due at midnight. The ship travels with a constant velocity. So velocity is given. Velocity vector is given. Velocity vector is given as 12i minus 60j kilometer per hour. A part, find the speed. So speed means modulus or magnitude of the velocity. So that is speed equal modulus of velocity vector. So that is square root of, you know how to find the modulus of a vector. So 12 squared plus 16 squared. So you will get 20 kilometer per hour. That's the answer. Simple. If you have a vector, to find its magnitude or modulus, a squared plus a, if it is a vector r is equal to ai plus bj, the magnitude of r is equal to square root of a squared plus b. It's a theory. Normally all teachers, they teach this. Yeah. Okay, so at time t hours after midnight, the position vector of s is s kilometer. Find an expression for s in terms of I, j and t. So you know the initial position vector of a moving object. You know the velocity vector of the same object. It's a constant velocity. They are saying it moving at a constant velocity. Yes, you know the constant velocity vector. So to find the position vector later, same question appears in all papers. Initial position vector plus velocity vector into time. That's all. Okay, so big part. So the position vector at time t, so I can call s is equal to initial position vector plus velocity vector into time. So initial position vector is given 19 I plus 22j, 99 plus 22j kilometers plus velocity vector into time. At time t they are asking. So velocity vector into time t. So that is 19I plus 22j plus velocity vector. We know that 12y minus 16j into t. Solve it. If you want to take I common, if you solve it, you will get 19 plus 12t I plus 22 minus 16t j. This is the position vector of the ship S at time t later. Okay, at time t hours after midnight, the position vector of S, okay, we did that B part. Now, a lighthouse stands on a small rocky island. The lighthouse is modeled as being at the point with the position vector 26I plus 15j kilometers. It is not safe for ships to be within 1.3 kilometer of the lighthouse. Okay, now we'll put it on a diagram for that. I can use the same thing. Yeah, so C part. Now this is the origin. They are saying everything is measured relative to origin O. So all the vectors, unit vectors are measured relative to O. So the lighthouse, we don't know where. I just take the lighthouse, name it as L. Okay, this is the L. So L, that OL is the position vector of the lighthouse, that is 26I plus 15j kilometers, 15j, yeah, kilometer. Right. The position vector of the ship is, at time t, is 19 plus 20. So I'll put the position vector of S here. This is the ship. So this is the position vector S. This is OL. I can name it the lighthouse vector L. We'll use that L. Okay. So this is the position vector of ship that is given by this. I'm not writing the whole thing again. So that is the position vector of S. Okay. And it is not safe for the ship to be within 31.3 kilometer of the lighthouse. So the position vector is a time function. You can see there's a time. So with the time, the position vector is going to change. With the time, the position vector is going to change, right? They are saying it's not safe to be within a distance of 1.3 kilometer from the lighthouse. So that means the distance of the ship from the lighthouse should be always more than 1.3 kilometer. How to find that? So it's like this. We'll find the vector LS. that is the vector S relative to L, we will find it, because from the lighthouse I need to get the distance of the ship. Means I know the position vector of S at time t, this one, that is OS I know, OL I know, I need to get LS. LS means, the vector LS means that's going to be the vector of S relative to L. The vector LS I need to find it. Okay, so position vector of S relative to L I am going to find. So we will find LS. If I find the modulus of it, that will be the distance of S from L. So position vector LS is going to be LO plus OS. So LO means minus OL plus OS. Minus OL means that is 26I plus 15J all in minus, plus OS, that is the S position vector at time t, 19 plus 12ti plus 22 minus 16g j. Right, we know the LS now. Okay, so now rearrange that. Solve it. Minus 26i, here minus 19i, so it's going to be minus 7i. Then in terms of t here, solve this one. You will get LS, that will be 12t minus 7 minus 7i, 12t minus 7i. So here 26i, here 19i plus 12t. So that you will get here minus 26, is it? So that's going to be minus 26 plus 19, it's going to be minus 7, 12t, yes. So 12t minus 7i plus 16t minus 16t plus 7j, that is the vector LS. Okay, so the distance of S from L should be less than 1.3 kilometers. So this is given in kilometers. So this we can say in kilometers. Okay, so the distance of ship from lighthouse should be less than 1.3, means we need to find the modulus of this vector. That gives the distance of S from L. So mod LS is the distance of S from lighthouse L. Okay, how to find that distance so that we can take the modulus of LS, let it be x. So x is equal to, or x squared, we can keep it in square, x squared is equal to you take some, it's like x is equal to, that's the modulus of LS, I'll take x, that's the distance, equal to square root of this square plus this square. So that is 12t minus 7 all in squared plus minus 16t plus 7 all in square. Okay, so inside we had expand and rearrange it. So if you expand and rearrange, you will get 144 t squared plus 49 inside minus 168 t plus here 256 t squared minus 224 t plus 49 all in square root, or I can say instead of square root I can put to the power half, square root or to the power half. Okay. I can put square root or to the power half. That is x is the distance of ship from L modulus ls vector. Okay, we'll continue that. You rearrange it. Okay, I'll continue here. That is x is equal to, if you rearrange that one, you will get 400 t squared minus 392 t plus 98 to the power of half. Okay, so they are saying the distance, the question says that a lighthouse stands on a smaller, okay, they are giving that. It is not safe for the ships to be within 1.3 kilometers. So it should be away, the ship should be more than at a distance of 1.3 kilometer from the lighthouse. So we'll find what could be the closest distance the ship approaches from the lighthouse. The closest distance of the ship from the lighthouse means the minimum distance of the ship from the lighthouse means I need to find the minimum value of x, because x is a function of time. When the time changes, x is going to change. So it's a function of x with respect to time. I need to find the possible minimum value of x, so I need to differentiate it. Okay, so dx over dt will take it. Dx over dt is going to be half into 400 t squared minus 392 t plus 98 to the power minus half into differentiate inside. So minus half, so it's going to be denominator. Now this is the important part, that is 800 t, if you differentiate here, 800 t minus 392, that must be equal to 0, and minimum or maximum dx over dt must be 0. We have to find minimum, right? So that must be equal to 0. So when we find this equal to 0 means this is numerator, sorry, it's a denominator, minus half. So we don't need to consider that. Only thing we need to consider, this decides the value of 0. So 800t minus 392 equal to 0. From that find the t. 392 divided by 800, you will get t that is equal to 0.49 hours. 0.49 hours. So that is the time. And it will become closer to the lighthouse. The ship will become closer to the lighthouse at a time of 0.49 hours after the midnight. Okay, so we'll find what could be the minimum distance. So x minimum, we'll see the x closest, or x minimum, we'll find it, the closest distance of the ship from the lighthouse. For that, we need to substitute this value in this equation. The closest distance, we need to find it. So substitute the time, this one in here, that is going to be 400 into 0.49 square. I'm substituting the minimum, the time that required to reach the point which is closer to the lighthouse. So that time is substituted in here to find the closest distance. So minus 392 into 0.49 plus 98 plus 98 to the power of half, the square root. Solve it, all numbers. You will get 1.4 kilometer, that is greater than 1.3 kilometer. So safe to continue the journey. So the closest distance of the ship from the lighthouse is 1.4 kilometer, which is more than 1.3. The question says it should not come closer than 1.3 kilometer from the lighthouse, so it can continue its motion. So safe to continue the motion. Safe to continue the journey. Okay. So this should be the second part. First part, that one. So this could be the first part, C part. This is the second part. Second part says hence determine whether it's safe to is to first part value of t, find the value of t when s is closer. So we found the value of t, right? So that is here. Until this first part. So this is the second part. I did everything together. So first part is ending here. This is the second part of question C, part C. Okay, anyway. Okay, question number 8. So a diagram is given, inclined plane. A fixed rough plane is inclined at an angle alpha to the horizontal, tan alpha 5 by 12. A diagram is given there. A smooth pulley is fixed at the top of the plate. One end of the light inextensible string is attached to the particle P, which is at rest on the plane. The string passes over the pulley and the other end of the string is attached to a particle Q, which hangs vertically below the pulley. Particle P has a mass m and Q has 0.5 m. The string from P to the pulley lies along the line of greatest slope. The coefficient of friction is given mu. The system is in limiting equilibrium with the string taut and P is on the point of slipping up. Slipping up means friction is going to be down, right? Also, you must know when object is kept on an inclined plane, like on a slope, if an object is kept there, its weight will act vertically downwards, mg. If this angle is theta, the weight could be resolved in two right angle components. The component of the weight along the plane down will be mg sin and theta. The component of the weight along the plane down is mg sin theta. Remember that. Component of the weight perpendicular to the plane is mg cos theta. So I don't need to consider the mg now because I resolved the weight into two right angle components. One component along the slope, which is mg sin theta. The other one is perpendicular to the slope. So the normal reaction will act perpendicular to the slope. The normal reaction will be along this way. That is the contact force, the normal reaction from the plane. Okay, so normally when the object is at rest or when the object moves along the plane, there is no motion or no acceleration perpendicular to the plane. When object moves along the plane or when it is at rest, there is no motion, no resultant force along the plane perpendicular to the plane. No force, no resultant force perpendicular to the plane. Means when I consider perpendicular to the force this direction, the resultant force must be 0, means R minus mg cos theta equal to 0. So the normal reaction equal to mg cos theta. Remember these things as theory. Then if the object is on a rough plane and it's about to slip down, means the friction will be upward direction. That will be equal to F equal the friction mu R at the limiting state. At the limiting state, if the friction will be F equal mu R equal mg cos theta. If the object is about to move upward direction, something like in this question they are passing attached to a string and try to slip upward direction due to the weight hang on the other side of the pulley, then the friction will be downward direction, that is mu R, F equal mu R equal mg cos theta. So these are the theories you must know to answer this question. So in this question, the weight is acting along the plane down, that is mg sin alpha, the component of the weight along the plane down, mg sin alpha, and the sphere is about to slip upward direction. So it's about to slip upward direction means the friction will be opposite to the motion. So F equal mu R in this direction. F equal mu R, this direction. The normal reaction will be this direction. This is the normal reaction. Normal reaction will be this direction R. The component of the weight along the plane perpendicular to the plane is mg cos alpha. The component of the weight along the plane mg sin alpha. So component of the weight along the plane down mg sin alpha. Component of the weight perpendicular slope is mg cos alpha. Normal reaction, the friction is downwards. Okay, when you consider the second uh, sphere which is on the other side, that is Q, this is P. When you consider the Q, it's passing over, and there will be tension also. I didn't mark it. The tension also there. On the sphere, there's a tension also on P. Okay. When you consider the sphere which is hanging on the other side, I am not drawing all. I am drawing only the forces. So the weight will act down. So that is 0.5. This is Q. 0.5 mg. The mass is 0.5 m. So 0.5 mg. Same tension, because same string, same tension. So the tension acting here is T. Okay, so these are the forces acting on the two spheres. The question is, find the value of mu. So there it's given tan alpha equal 5 over 12. So that means if you think about a triangle, alpha this angle, tan alpha means 5 over 12. So this side length will be 13, Pythagoras theorem. So cos alpha is equal to 12 or cos alpha will be 12 over 13, then sin alpha 5 over 13. We can use this later. Okay, so it's limiting equilibrium, so we need to find the mu. So we know that R is equal to, for the P, or for the P when I consider, for the P, R is equal to mg cos alpha we can substitute 12 over 13, so that is going to be 12 mg over 13. Okay, so the friction, how much will be the friction? The friction force Fr is going to be mu R, that is mu into R equal to 12 mg. So 12 mu mg over 13 is the friction. Okay, so they are saying it's at rest, but limiting limiting friction is acting. So along the slope when we consider, the resultant force must be equal to 0. Here also the moment about any point must be 0. We don't need to take the moment because we don't have any dimension of the two spheres. But we know it's at rest means the resultant force along the slope must be 0. So if I use along the slope, that is T. For P, when I use it along the slope, I am using P means T minus mg sin alpha minus the friction Fr is equal to 0. But for Q if I write, T equals 0.5 mg. So for Q if I write, I'll write it here. For Q if I consider, there are only two forces acting. So T must be equal to, upward force must be equal to downward force 0.5 mg. Same tension is acting here. So instead of T I can put 0.5 mg. I got it from Q because Q is also at rest. So 0.5 mg minus mg sin alpha is 5 over 13 minus Fr is equal to 12 mu mg over 13 equal 0. All the mg will get cancelled. So solve it, you will get 6.5 minus 5 equal 12 mu. Find the mu. You will get, solve it, you will get 1 over 8. That's the coefficient of friction. Just I using the equilibrium condition for Q, that is for Q, the T must be the upward force equal downward force or the resultant force 0. So from that I found T equal 0.5 mg because it's at rest, limiting equilibrium. Then for P, the resultant force along the slope is resultant force 0. So T minus mg sin alpha, the component of the weight along the slope down, mg sin alpha minus Fr equals 0. Fr is equal mu R equal mg cos alpha. So substitute everything, you will get mu equal 1 over 8. Okay, so second part, the B part. The string breaks and P begins to move down the plane. So the friction is going to be upwards on P. When the particle P has traveled a distance of 0.8 meter down the plane, the speed of P is V meter per second. Find the speed P. Okay, we'll find the acceleration first. So we know the mu. So when it string breaks, the tension will become zero, no further tension. But there will be friction upward direction. So that this friction will act upward direction. So for the B part, now if I draw the diagram, the component of the weight will act downwards, that is mg sine alpha. There is no change in that one. But the friction is acting upward direction. Fr equal mu r, that will act upward direction because it's moving downward direction. Okay, so we'll use F equal ma along the plane down. We need to find the resultant force along the plane down, and we'll find the acceleration. Then we'll find the speed. Okay, so the diagram drawn for part B. So the resultant force, I need to find it. The friction is acting upward direction when the string breaks because it's moving down. The component of the weight along the slope down mg sine alpha, we know the values of sine and cos if you want. The friction equal F equal mu r equal mg cos alpha. So the resultant force along the slope down, I need to find it first. So we'll find the resultant force along the slope down. That is B part, I already put it. So along the plane down, F equal ma, I am going to use. The resultant force is mg sine alpha minus mu r equal ma. So mg sine alpha 5 over 13 minus mu, we found it now, 1 over 8. R equal mg cos alpha. mg r equal mg cos alpha. Cos alpha 12 over 13 equal ma. So all the m will get cancelled. G we know that is 9.81. So when you solve that, you will get finally 5 into 9.8 over 13 minus 9.8 over 9.8 into 12 over 8 into 13. 8 into 13. Yeah, is equal to all the m got cancelled, is equal to a. So solve it, you will get a is equal to the acceleration along the slope down. You solve it, you will get 2.64 meter per second square. Okay, so when the string breaks, at that moment it was at rest. Now it's going to move down, accelerate uniformly at constant acceleration. So along the plane down, the question is find the speed when the distance it moved is 0.8 meters. So we'll use v squared equal u squared plus 2a along the slope down. So it was at rest, 2 into acceleration 2.64. It moved along the slope down 0.8 meters. We need to find the speed. That will be 2.06 meter per second. Okay, that's the answer for the motion along the slope down. Okay, so I hope you understood this. That's all the questions I have done all. So you can see the theory, the applications, all papers are the same. So nothing to worry about the questions. Same type, same idea repeated most of the past papers. By using the playlist of this channel, you can navigate to any video related to physics or mathematics. Okay, bye.